prismatic beams. Prismatic beam is a prismatic cylinder body with straight center line and constant cross-section. What do I mean by prismatic? For example, for beam AE, this is considered a prismatic beam kasi yung cross-section from A hanggang kay point E ay pareho. So, constant yung kanilang cross-section. Or at saka yung kanilang mga moment of inertia pare-pareho yun. So, that is a prismatic beam. Now, looking at this diagram, if we're going to apply a certain load P at that point, your beam will tend to deflect like that. So, that is an exaggerated elastic curve. Now, in here, mayroon tayong dalawang values na nakukuha dito. That distance from the original position of your beam hanggang dun sa may deflection, that is what we call, yan is mo yung deflection or yung displacement ng beam mo. That distance. Maaari din namang sabihin kong deflection din yung from here up to here. This is also a deflection. So, I'll say this is point B. Pwede rin namang, kung ito si point C, yung distance from the original position of the beam hanggang dun kay may elastic curve, this is also a deflection. But, itong point na to kasi, kung mapapansin ninyo, this is almost flat. Itong part na to, flat na siya. Ito ngayon yung tinatawag nating maximum deflection. Now, kapag simply supported beam at saka yung load mo is located at the center or the mismong sentro nung inyong beam, the maximum deflection is malapit dun sa may mid-span. Okay? Another na pwede nating makuha in here is yung tinatawag nating slope. So, if I'm going to draw a line that is tangent to my elastic curve, and that angle, yung angle na yun, dyan magro-rotate yung ating point. So, we call that your slope. So, from this diagram, we can, there are two unknowns, the deflection and the slope at a certain point. Na paano ba nako-compute itong mga deflection and slope? There are different methods for the analysis or for the determination of your slope and the deflection. Pero ang uunahin muna natin is the double integration method. From that word integration, this is an application of your integral calculus. Now, before I go further, let's go back to your integral calculus. Ang rule na ginagamit natin in double integration method is your power rule. Anong sabi dun sa may power rule during your integral calculus? So, for the integral of base x raised to n dx, that is equal to x n plus 1 over n plus 1 plus c. And pinag-aralan nyo ito during your integral calculus. Now, since double integration tayo, twice nating kinukuha yung integration ng ating x over n, ay xn. So, paano ba yun? Let's have an example. Let's say for this one, double integral of x cubed dx. So, paano siya? First is, we have to take the integration of your x cubed dx. That is, x, your n is 3, so plus 1 over n plus 1, 3 plus 1, plus c. Bakit c1? Kasi, di ba, twice ko siyang i-integrate. So, simplifying this, that is x raised to 4 over 4 plus c1. Again, itong value na to, itong x raised to 4 over 4 plus c1, i-integrate natin siya ulit. And this is now my answer. So, x raised to 4 plus 1 over 4. This time, since naging coefficient na ngayon itong over 4 na ito, you have to multiply that dun sa may n plus 1. N plus, di ba, from your power rule, the integral of a constant is constant times that of x. Do not forget that one, the power rule of your that was discussed during your integral calculus. So, let's have an example for this beam. Now, for this beam, these are the steps in using the double integration method. So, let's say ito yung beam. There is a concentrated load applied at that point 2 meters from your left support. So, ang pinakaunang gagawin ko, magdodraw ako ngayon ng line kung saan makukuha lahat ng mga loads. So, dito ako magka-cut. And that distance from my left is x. First is I have to make a moment equation. So, kung dito ngayon yung cutting plane ko, dyan ako magmo-moment. So, kung magmo-moment si RA doon kay may cutting plane ko, that is RA multiplied by X, that is the moment arm. Again, ang notation natin dito is positive ang clockwise, negative ang counterclockwise. So, RA will rotate clockwise at my cutting plane. The distance is X minus P times the distance of P hanggang dito kay may cutting plane ko is X minus 2. Right? That is my moment equation. After na nakakuha na ako ng moment equation, I have to take the integral of this equation. So, yung exponent ni x ko dito is 1. Right? So, kapag i-integrate ko siya ngayon, that is RA, yung x ang magiging exponent na ngayon is 2 over n plus 1, that is 2. Nakita nyo paano ang ginawa yun? Minus P x minus 2, wag ninyong isi-simplify. Let the values inside the parentheses, ganyan lang siya, wag niyo siyang isi-simplify. Then the exponent, yung nandito sa may parentheses is 1. So if I'm going to take the integral of that, yung exponent na magiging 2, then I have to take na yung exponent ay nasa denominator. Itong equation na to, itong first na integration ninyo, this is what we call now your EI theta. Itong theta na ito ngayon, this is your slope. Okay? So, pag tapos na natin na-integrate, next is integrate ulit natin kasi nga dalawang beses tayo mag-i-integrate. Okay. This time, RA over 2 times x squared. Dito sa may first integration kasi natin, the exponent is 2 plus 1, kaya naging 3. And do not forget, yung exponent dito dapat ilalagay din sa may denominator. Kaya dun ko nakuha si 3. Same with this one, P, x minus 2 raised to 2, kapag in-integrate ko ulit, that is x minus 2 raised to 3. Yung exponent ko na 3, nilagay ko sa my denominator. So, ito yung magiging second na integration ko. Now, itong equation na to, that is the equation for your deflection. Itong y na ito, this is now your deflection. And take note, this I is the modulus of elasticity. Itong I na to, that is the moment of inertia nung beam. Okay? Let's have an example. Ito yung nasa notes ninyo. Determine the displacement and the slope at the midspan of the simply supported beam shown. So, this is a simply supported beam. Ang pinakaunang gagawin ninyo is to determine the reactions at each support. So, I've already computed it. The reaction at point A is equal to 8.8. The reaction at point E is 14.2. After na nakuha ninyo lahat ng mga reactions sa support, you have now to put a cutting plane. Now, take note of this. Kapag maglalagay kayo ng cutting plane, make sure na yung plane na yon mako-cover niya lahat ng mga loads. So, if I'm going to proceed with this one, ang cutting plane ko is between D to E. Saan ko ilalagay si x? That is from my left. From A hanggang dun sa may cutting plane ko, that is x. Kung gusto nyo naman, pwede rin naman na ang cutting plane nyo dito. But make sure na yung x ninyo ay hanggang kay E. Basta ang tandaan nyo lang, dapat kapag nag-consider na ako ng x, makukuha niya lahat ng mga forces. Ay, lahat ng mga forces. After that, kapag nakalagay na ako ng cutting plane ko, and yung x ko, next na gagawin ko ngayon is to make my moment equation. So from here, since dito yung cutting plane ko at ang kinonsider ko from left to right, si RA ngayon, kapag magmo-moment dito sa may cutting plane, that is 8.8, the distance is x. Right? Ito namang 5 na to. Kapag nag-moment dito sa point na to, that is 5. Since that is downwards, kaya counterclockwise minus 5. The moment arm or the distance of 5 hanggang dun kay cutting plane ko is this one. And what is this distance? That is x minus 2. Next, itong 10 na to, kapag magmo-moment kay point na to, that is counterclockwise, so minus. The distance of this 10 hanggang kay cutting plane ko is x minus 6. Saan ko nakuha si x minus 6? Itong distance na to ay yung x minus 6. Okay? Then 8 counterclockwise pag nag-moment dito. And this distance is equal to x minus 9. So, yan ang lagi niyong tandaan. In making your moment equation, make sure na yung almost lahat ng mga loads na yung nako-consider ninyo. Especially yung mga external loads, nako-consider yung mga yun. And after na nakuha natin yung moment equation, pwede na tayong mag-integrate ngayon. So, kung i-integrate ko yung 8.8x magiging 8.8 over 2x squared. Again, do not simplify yung mga nasa loob ng parenthesis. Let it be like that. Huwag nyong isi-simplify. Then, itong 5, the quantity x minus 2, kapag in-integrate ko siya, magiging 5 over 2 x minus 2 squared. Same with the quantity 10, x minus 6, that is 10 over 2, x minus 6 raised to 2. Then, 8 over 2x minus 9 raised to 2. Now, do not forget, ano itong a na to? Diba yung dun sa may integral calculus nyo kasi, kapag in-integrate ninyo, ang ginagawa natin is plus C1. Ngayon, ang ginawa ko lang, yung C1, ginawa kong a. Walang problema kung gusto nyong mag-stick dun sa may C1. Wala akong problema dun. But as for me kasi, sinusunod ko lang yung may dun sa libro na ginagamit ko. Pareho lang itong A na ito dun sa may C1 na napag-aralan natin during our integral calculus. Do not be confused by that. And so, after the first integration, pwede na akong mag-integrate ulit. So, for the second integration, 8.2 over 2 raised to 2, kapag in-integrate ko siya ulit, magiging 8.8 over 6 x raised to 3. Okay? Then, itong 5 over 2x minus 2 raised to 2, magiging 5 over 6x minus 2 raised to 3. Paano naguha yung 6, yung denominator na 6 na ito? Diba, dito, the exponent of x is 2. So, pag nag-plus 1 ako, 3. 2 times 3 is 6. Okay? The integral of a constant is constant times x. Kaya yung integral ng a ay ax. Now, what is this b? Itong b na ito, siya rin yung Doon sa may calculus natin, siya rin si C2. Iniba ko lang, pero pareho lang siya. So, yung first integration natin, do not forget, that is the equation for your slope. The second integration, that is the equation for your deflection. So, yan yung mga equation natin. Now, balikan natin yung problem. Ang sabi dun sa problem, determine the displacement and the slope at the midspan of the simply supported beam. So, ang hinahanap natin dito is the deflection or the displacement and the slope. So, again, if I'm going to draw or exaggerate the elastic curve of this beam, ganyan siya. And midspan, the midspan of this beam is 4, 5, 6, somewhere here. Andito yung midspan natin. So, ang displacement na hinahanap is from this point hanggang dito sa point na to, ito yung hinahanap natin na displacement. At yung slope naman at the midspan. The slope at the midspan. So, since andito yung midspan, if I'm going to draw a tangent line passing through that center point, yan yung slope. And makikita niyo dito sa figure, kung ito yung slope, straight line siya. And if that is a straight line, the slope is 0. So, ang kulang na lang natin is this deflection. Yan na lang ang hahanapin natin, yung deflection mismo. Now, paano kukunin yung deflection using these equations? So, ang gagamitin natin na equation ay itong EIY na ito. Masusolve ko si y, yung value ng y, kapag alam ko si x, pag alam ko si a, at saka si b. EI, hindi given sa problem, but this is given usually kasi alam na natin yung cross-section ng beam at saka yung modulus of elasticity ng steel. But moving forward, makusolve ko si y, basta alam ko si x, si a, at saka si b. So, paano ko makukuha si a, x, and b? Now, first na gagawin nyo, look for a point kung saan magzi-zero si y. Again, look for a point kung saan magzi-zero si y. As for my case, I'm going to choose point A. Kasi kay point A, support ito eh. So, dito, hindi bababa or walang deflection na magaganap kay point A kasi may support doon. So, x that is equal to 0, y is equal to 0. Tama? So, again, using this equation, itong kay EIY. Kay EIY, kinopya ko lang siya. Magzi-0 si x. So, kung magzi-0 si x, wala na itong 8.8 over 6. Wala na rin si AX. Tama? But, take note, look at this one. If I'm going to substitute 0 dito sa may, wait lang, dito, kung papalitan ko itong x ng 0, 0 minus 2. Tama? And the answer to this will be negative 2. Now, in using double integration, if the value inside the parenthesis is a negative value, you have to disregard that one. Ulit, if the value inside the parenthesis is 0 or a negative value, you have to ignore it. Ito, 8 over 6x minus 9. Kapag si x pinalitan ko ng 0, 0 minus 9 is a negative value. So, ignore that again. Okay? Then, since y now is 0, my b is equal to 0. Next, pili ako ulit ng point kung saan magzi-0 pa si y. So, if I'm going to consider now point E, the same equation ko sa may EIY, ngayon this time, the value of my x is 10. So, kokopyahin ko lang ulit yung equation na 8.8 over 6x cubed minus 5 over 6x minus 2 cubed minus 10 over 6x minus 6 cubed. Okay, yung equation na yun, kokopyahin ko lang. Then I'm going to substitute the value of x by 10. Magzi-0 si y. So, isa-substitute ko lang si x ng 10. Now, kindly get your calculators. Compute the value of a. This is what I have solved. A is equal to negative 93.2. So, nakuha na natin yung value ni B at saka ni A. We can now determine the displacement. Again, ang hinahanap dito is the displacement at the midspan. So, since displacement, ang gagamitin nating equation ay yung EIY. Now, since midspan yung hinahanap, we know that at midspan, x is equal to 5. Diba? The whole length of that beam is equal to 2, 4, 6, 8, 10. The midspan is located 5 meters from my point A. So, I'm going to substitute x dun sa my EIY equation. So, lahat ng x dito, papalitan ko ng 5. At since may value na ako ng B at saka A, direct substitution lang tayo. As always, if the value inside the parentheses is 0 or a negative value, you have to ignore that. Kaya in-ignore ko yung itong 5 minus 6 kasi negative siya. 5 minus 9, negative din yung value nun. So, ignore that one. Ito na ngayon yung magiging EIY equation ko. Simplifying this, my EIY is equal to 305.2. Y ang concern ko, hindi EIY. Y ang concern ko. Therefore, now the value of my Y, or yung deflection ko, or displacement ko, is equal to negative 305.2 times 10 raised to 3 over EI millimeters. Ay, ano itong negative value na ito? Itong negative value na ito, it shows na yung ating deflection ay matatagpuan below the beam. So, yung ating deflection ay, kung ito ang midspan, kung nandito yung midspan, yung ating deflection daw, from the original position hanggang dito. This is your Y. Ay, nasa baba siya ng original position ng beam. For the second illustration, the simply supported beam has a rectangular cross-section. The beam supports a concentrated load of 300 kilonewtons located at 2 meters from the left support. You're required to determine the maximum displacement and the slope at point C. So, dalawang hinahanap natin dito. Yung value ng maximum displacement at saka yung slope at point C. If I'm going to draw the elastic curve for this beam, it will look like this one. The maximum displacement is somewhat located at this part. Mati-check natin mamaya kung saan eksakto itong value ng ating maximum displacement. Now, if I'm going to draw a tangent line passing through point C, tangent line, yung rotation or yung slope na sinasabi natin is this value. Okay? Yan yung ating hinahanap. So, very first thing you have to do, determine the reactions for each support. So, again, using your equilibrium equations, the value of the reaction at point A is 100. At point C, that is 200 kilonewtons. After na nakuha natin yung ating support reactions, since given naman yung cross-section, I can solve for the moment of inertia of my beam. Bakit ko kinonvert ito ng meters? Kasi kung mapapansin ninyo, naka-meter lahat ng mga distances. For my convenience, I converted the moment of inertia into meters. Then given naman si E, that is 12 gigapascal, I can solve now the value of my EI, that is equal to 20.48 times 10 raised to 3 Newton meter squared. Then, pwede na akong mag-drawing ng aking moment equation. So, ang moment equation ko, nag-cut ako ng plane between B to C. Then, I considered from point A hanggang kay cutting plane ko, nandun si point X. So, kapag magmo-moment itong 100 kN na to hanggang dun sa may cutting plane, that is 100 times X. Itong 300, kapag magmo-moment naman, that is 300 times, the distance is X minus 2. Again, that is my equation 1. That is my moment equation. Next, integrate that one. Kapag in-integrate ko si 100x, magiging 100 over 2x squared. Si 300, x o minus 2, pag in-integrate ko naman siya, magiging 300 over 2, x minus 2 squared. Do not forget, there will always be a constant value, so plus a. That is now my second equation. So, integrate this again, itong equation 2. Pag in-integrate ko siya, magiging yan. Yung 100 over 2x squared, magiging 100 over 6x cubed. Yung 300 over 2x minus 2 squared, magiging 300 over 6x minus 2 cubed. Plus, the integration of I constant is A is constant times x, so EX plus B. Ito na ngayon yung mga bagong equations ko to determine the maximum displacement. Okay, going back to the problem, ang hinahanap natin dito yung maximum displacement at saka yung slope at point C. Nakuha na natin yung equations 1, 2, and 3. Next, I need to determine the value of my A and B. Kaya nang ginawa natin in the previous problem. In equation 3, I'm going to choose point A, wherein x is equal to 0, and y is equal to 0. Y is equal to 0 kasi may support doon. So, kung kukopyahin ko yung equation 3, and I'm going to substitute the value of x by 0, ma-eliminate si EIY kasi 0 si y. Pati ito ma-eliminate. Ma-eliminate din si AX. Now, dito sa loob ng parenthesis na to, kapag sinubstitute ko si x ng 0, magiging negative yun, di ba? Kaya I'm going to ignore that 1. My b now is equal to 0. Again, if I'm going to choose when x is equal to 3, kasi nandun yung isang support kay point C, y is equal to 0 din. So again, in equation 3, I'm going to substitute the value of x by 3. But take note, my y is equal to 0. B is also equal to 0. And the value of my A is equal to negative 133.33. Yan. So, nakuha ko na si value ni B at saka ni A. Ngayon, I need to determine the value or kung saan eksakto yung maximum displacement ko. Paano ko makukuha yung eksaktong location ng maximum displacement? For maximum deflection or displacement, it occurs where the slope of the elastic curve is 0. Anong ibig sabihin nito? Diba kapag ino-drawing ko ulit yung aking elastic curve, let's say, yan yun. And let's say, nandito sa banda dito yung ating maximum deflection. Now, if I'm going to draw a tangent line passing through dun sa may location ng ating maximum deflection, let's say at this point, the slope is equal to 0 kasi straight line na siya. Okay? The slope of the elastic curve is 0. Therefore, kukunin ko yung equation kung saan ang slope. dy over dx is, yan yung ating slope. So, I'm going to use equation 2. Now, in equation 2, since maximum displacement, magzi-zero si dy over dx kasi nga, yung location ng maximum displacement, 0 yung kanyang slope. Then, alam ko yung value ni A kanina, that is negative 133.33. Therefore, I can solve the value of my x. But, before I'm going to solve for the value of x, let's take a look at this one. Yung, kung titignan ko sa diagram, yung aking maximum deflection, nandito siya sa banda dito. So, hindi siya lumagpas kay 2 meters. That is lower than 2 meters. Therefore, kapag lower than 2 meters, mai-ignore ngayon itong value na ito. Kasi, any value lower than 2, pag substitute ko siya dito, magiging negative. Tama? Kaya, I'm going to ignore that one. So, ito, ganyan na lang yung maiiwang equation ko. Isa-substitute ko lang si A ng negative 133.33. The value of my x is 1.6333 meters. Ano tong x na to? Yan yung location ng ating maximum displacement. So, from point A hanggang dito, that is 1.633 meters. See, that is lower than 2 meters. Okay? So, after na nakuha ko na si x, makukuha ko na yung maximum displacement ko. Again, using EIY. Substitute x as 1.633. May value na ako ni B at saka ni A. And, since 1.6333 is less than 2, mai-ignore itong part na to. Kasi negative yung nasa loob ng parenthesis. Now, if you're going to input these values in your calculator, my EIY is equal to negative 145.15. Again, this is not yet my final answer. Ang hinahanap ko dito ay si Y, hindi si EIY. So, going further, EIY is negative 145.15. And, nasolve na natin kanina si EI, that is equal to 20.48 times 10 raised to 3 Newton meter squared. Substituting the value, my Y is equal now to negative 7.09 times 10 raised to negative 3 meters. In millimeters, the value of my Y is equal to 7.09 millimeters. Inalis ko na ngayon si negative. Ang magiging direction ngayon ng aking deflection is downwards. Again, yung negative value dito, it indicates the direction of your deflection. Right? The same. Dito sa may beam na yon, nakuha na natin si maximum displacement. This time na ngayon, yung slope at point C. Since nakuha na natin si equation 1, 2, and 3, at saka alam na natin yung value ni B at saka ni A, madali na lang na isolve yung deflection, yung slope at point C. I'm going to use equation 2. For slope at point C, the value of my x is 3. So, in equation 2, substitute lang natin si x by 3. But, again, take note, kapag yung nasa loob ng parenthesis negative siya, i-ignore nyo yun. But, since 3 is greater than 2, walang problema. Substituting the values, the slope is equal to 166.67 over EI, or that is equal to 8.14 times 10 raised to negative 3 radians. Convert this into degrees, that is equal to 0.47 degrees. CCW stands for counterclockwise. Paano ko nasabing counterclockwise yung magiging rotation ni point C? You have to take note, according to the sign convention for slopes, the positive value for theta means that the beam rotates counterclockwise. So, for instance, yung nakuha nyong value for theta is a negative value. The final answer is that point will rotate clockwise. But since the slope computed in this problem is a positive value, the rotation will be counterclockwise. And so I hope illustration problem number 2 is medyo okay na. Clear tayo dun. I would just like to add another example. Especially kapag madami ng loads na nilagay dun sa may beam. Just like for example, this cantilever beam. So, pag nakikita nyo itong beam na to, ang support lang natin is andito kay may point E. That is a fix. So, cantilever ito. If I'm going to draw the elastic curve of this cantilever beam, it will look like that. Walang support kay point A. And let's say, sa problem na to, ang hinahanap is the Ymax. Ymax is the same as yung ganyang sign. Maximum deflection ang hinahanap natin. So, sa diagram, maximum deflection obviously is at this point. Okay? So, paano natin isolve ngayon to? Always, the very first thing after solving the reactions, magdodrawing kayo ng cutting plane. Then, make sure na yung location ng X ninyo ay na-cover niya lahat, especially ng mga external loads. Okay? So, for this case, again, i-consider ko from left to right para makuha ko lahat ng mga external loads. After that, na nakuha ko na yung, ay naglagay na ako ng cutting plane at saka yung X, pwede na akong maglagay ng moment equation ko. Right? So, si 10kn, itong 10kn na to, kapag nag-moment kay point E, that is counterclockwise, so minus, the distance of this 10 is this one, from here hanggang dito. That is x minus 1. Itong 8km, 8km per meter. Again, this is a rectangle and it stop hanggang doon lang siya. Huwag niyong itutuloy hanggang kay point E kasi yung cutting natin is hanggang dito lang sa point na to. So, ang i-consider niya lang na area ay itong na-shade ng red. So, that is 8. Since this is a rectangle, the base is, ito siya ngayon, ito. This is x minus 2. Right? So, itong values na to, that is the area of your rectangle. Ano naman itong value na to? Itong value na to, that is the distance of your resultant hanggang dun sa may cutting plane. Okay? Minus, may concentrated load ako na 15 kilonewtons kay point D. The distance is x minus 4. Simplify that. Again, wag niyong gagalawin yung mga numbers or dun sa loob ng parenthesis. And, ginawa ko lang dito, pinagsama ko yung, since pareho naman yung x minus 2 doon, tsaka yung x minus 2 dito. So, in-square ko siya para hindi masyadong complicated pag tinitingnan. So, after na nakuha nyo yung moment equation, integrate that one. The first integration, that is the equation for your slope. Okay? The second integration, that is the equation for your displacement. Again, kindly take a look at your screen. Double check if the values I have inputted are correct. Kapag na-double check nyo na, can we solve for the value of the displacement at point A? Do not merely look at your screen. Again, kindly get your pens and your notes or any piece of paper. So, for the displacement at point A, hindi ko ito i-check. Nasa sa inyo na if you're going to do it or not. Okay, ang answer ko dito, the displacement at point A or the maximum displacement is equal to 1127.49 over EI. Again, this is just an exercise. Gusto ko lang ipakita kung paano ko nakuha yung moment equation. Kasi masasolve nyo naman yung displacement at saka yung slope basta dito sa pagkuha ng moment equation. Kasi kapag mali yung derivation nyo ng moment equation dito sa part na to, kapag mali ito, mali na lahat ng sagot. So, pinakita ko lang sa inyo kung paano kunin yung moment equation. Especially pag masyado ng pag combination na ng concentrated load at saka uniformly distributed load. Now, in the last page of your notes, dun sa may follow-up work, you're required to determine the deflection and slope at point C. And the slopes at the supports. This is a laboratory exercise. So again, you have to follow the format.